For millions of miles away, the Perseverance rover panned its camera across the barren red dirt, looking for its lost companion. Resting on a remote dune, it found a shattered piece of carbon fiber. When this image reached mission control, the engineering team understood the finality of it. The mission was over. The condition of this blade points to a high-speed impact, the end of a series of failures that began months before the crash. The victim was Ingenuity, a tiny 680-gram drone. While most space hardware costs billions, NASA built this one for roughly $80 million, using off-the-shelf consumer tech, like smartphone processors and cordless drill batteries. In early 2021, this machine achieved the first powered flight on another world, mirroring the fragile wooden structure that lifted off the sand at Kitty Hawk over a century ago. It was designed as a 30-day test. Instead, it lasted for 71 successful flights across an unforgiving landscape. Its destruction was not caused by a single event, but by the convergence of software glitches and environmental damage that finally caught up to it on Flight 72. Flying on Mars requires total autonomy. A signal from Earth takes at least 6 minutes to arrive, and there is no network of GPS satellites to guide vehicles. A downward-facing camera takes 30 black and white snapshots every second, comparing them to surface maps. But capturing an accidental color image made the frame unreadable. Missing a frame caused the drone to follow an erratic path to correct its position. While safety protocols triggered an emergency landing the first time this happened, the software flaw remained a ticking time bomb. As the software struggled, the physical hardware faced the Mars Monster, a massive planetary dust storm that choked the atmosphere and blocked the sun. Temperatures dropped to negative 125 degrees Celsius, while a layer of sand coated the solar panels, permanently reducing the drone's power generation. The cold destroyed the primary flight sensor. To keep flying, mission control engineers hacked the software, using basic smartphone gyroscopes as a backup. By the time Ingenuity prepared for Flight 72, it was flying with compromised power, backup sensors, and a navigation system prone to confusion. The final flight path sent the helicopter over a featureless dune. With nothing but smooth sand below, the navigation camera had no landmarks to track. The color image glitch struck again. Without landmarks to guide it, the AI lost its lock, triggering an immediate emergency drop. The helicopter plunged violently towards the surface, hitting a steep, uneven slope instead of a flat landing pad. Upon impact, the force against the angled sand snapped the spinning carbon fiber blades at their weakest points. With the software confused and the sensors compromised, the AI ran out of options over a landscape that gave it no room for error. With its blades and pieces, Ingenuity will never take to the Martian sky again. Yet the core systems, those off-the-shelf smartphone processors, survived the crash and remain fully operational. NASA has now repurposed the drone. Its remaining sensors are being used as a permanent weather station, gathering climate data from its final resting place. A machine built for a 30-day experiment outlived its lifespan by nearly 2 years, proving that flight on another world is possible and leaving behind a legacy that continues from the sand of the Jezero crater.